All right, so today we're going to be covering the second half, really I think it's the third half of 1.5 about rewriting equations. What I'm looking at here is going over more formulas and showing additional ways to solve or rewrite it for a particular variable that you're looking for. All right, so let's put a couple examples on here. So let's look at rewriting a formula for surface area. So let's say we have the formula S equals 2LW plus 2LH plus 2WH. And let's say that we are solving for L. So we're going to say solve for L. All right, so the first thing we're going to do is start isolating things. So what I want to do is get just the things that are just the terms that have L in them on one side and anything else on the other side. So S is good, and it looks like the 2WH is also good. So we're going to move it across. So the opposite of addition is subtraction. Now, when we rewrite, remember, we cannot combine S with this, but we can write them as tied together by subtraction. So equals 2LW plus 2LH. Now that we have the the L's on the same side, we're going to take and isolate them out by factoring. Now, we haven't learned this yet. It's a reversal of what you do when you do distributive property. So saying that, we're going to look at them, so we're going to take an L out of both of them. So it's the same as saying divide out an L. So when I take an L out, I have 2W plus 2H. And of course, if you rewrite the other side, the S minus 2H. All right, now, the opposite of multiplication, which is what's holding those two together, is division. So we're going to divide both sides by the 2W plus 2H. So our final answer is L equals S minus 2WH all over 2W plus 2H. Let me scoot that up. There you go. So that's just another example of how to solve. Now let's do another one. Let's say that we have the surface area of a cone. So we have S equals pi r squared plus pi r L. And we are solving, so solve for L. So to solve for L, once again, we isolate it from the other terms. If you notice, there's only one of them that has the L on it, so everybody else is going to go that way. So I'm going to go ahead and subtract pi r squared over. So I get S minus pi r squared equals pi r L. Now, like we said earlier on the last problem, it was held by multiplication, which is true for this one as well. So if I take and divide out the pi and the r on both sides, we will get L. So we have S minus pi r squared over pi r. Now, depending upon your teacher, they may want you to reduce this down further or bring it down a little further. You can do that if you make them into two separate fractions. So the first way to do this would make S over pi r minus, now if we reduce this, pi and pi cancel, and one of the r's cancel, leaving r behind. So this would be your reduced answer. As for my class, I will take either answer. Both answers are the same outcome when you put numbers in there. Okay, one more, and then this will be the end of the 1.5. So let's look at an area of a triangle. A equals half base times height. And I think we've done this one once before and we looked for the base. So let's now look for the height. So solve for h. To do that, we have a lot of multiplication going on the right side, which is where the h is at. So let's make this easier ourselves. Let's actually clear the fraction. So to clear a fraction, what we're going to do is multiply by whatever the denominator is, which in this case is 2. So I'm going to have 2a equals 2 times a half is 1, so that just makes it bh. So now you just have b and h held by multiplication. To undo that, you're going to divide by b so that you can get h isolated. So 2a over b equals h. That will be your final outcome. Okay. If you have any questions, remember, send me an email. As you go through this, remember, you are just moving things around by the rules. You are using your reverse distributive property. You are using addition and subtraction. You are doing multiplying and division. All of these rules are things that we've gone over, so we're not changing them. We're just using them in reverse to solve. Okay, great job.